Swayam Prabha. Digital India. Educated India.
Okay, this section of lecture is based on pump turbine, because you are using pump and turbine for your special turbine for your energy harvesting systems, and the concept is taken from one book, Basic Concept of Turbo Machinery, and this book is freely available, you can download also. Okay, this link is given, so later I will share this link so you can get. So, pump versus turbine. So, already I explained that pump actually it is taking energy from electricity, and you are giving energy to fluid. So, the fluid is moving from one point to another point, where turbine is just opposite. So, your actual fan, it is actually pump category, it is giving energy to the fluid, right. And so, what is transfer of energy between rotor and a fluid, typically a gas or liquid. Okay, turbine extract energy from a fluid flow and convert into in mechanical work, and finally it is normally we convert into electricity. Okay, in many cases we do not convert into electricity. For example, if you want to use for water pumping and groundwater lifting, right. So, in that case directly you can use this rotation for pumping groundwater. So, without converting into electricity. So, turbine aerodynamics, fluid flows, an object extracts force on the object. Okay. So, this design actually right side if you see, yeah. So, right side this picture actually we design for a wave energy converter. Okay. So, this is called unidirectional, yeah, this one. You see this wave energy converter turbines, oscillative water column uses turbine. I think professor has already taught in previous lecture you have seen. Wave energy converter will have one hole, there you can put turbine and wave will be coming and it will be sucking or exhaling or inhaling air, and inhaling and exhaling air, there you are putting one turbine. So, there are two types of turbines, one is called Wells turbine and they call impulse turbine. Wells turbine called reaction turbine, impulse turbine is impulse turbine, the name. Okay. So, impulse turbine is like this, you can see this, these are called guide vanes, this blue color part guide vanes and red color part here, these are called blades. So, when air is flowing, so guide vane is like this, okay, I am drawing, you can see, and my blade is like this. So, fluid will be passing through this, it will go like this, and there will be another guide vane, okay, it will be passing through guide vane. So, air guided through guide vane, it will be hitting this impulse turbines, crescent shape like moon, half moon. Okay. So, when it is hitting, air is changing direction. When it is changing direction, it will give some energy to the turbine blade. Okay. When it is giving energy, so blade will get force. So, it will try to rotate. So, air is blowing, guide vane is giving angle, then it is hitting the crescent shape blade will get energy. Then when it is exiting the blade, the air, it will be going through again guide vane, it will be exiting, done. So, what air has done, air passed through guide vane will not take energy, he will say like, okay, I do not need any energy, just you go, okay, but it will give proper direction. So, proper direction so that blade can be hit properly. Okay. So, blade when air is turning angle, so it will be giving some, it will be changing momentum. When momentum changing, it will give some energy to the turbine blade. Okay. When turbine blade is getting energy, it will try to rotate. So, one blade is giving some, getting energy, another blade, all the 24, 36 blades getting some energy, all together it will be rotating. Okay. So, when in oscillating water column, big cylinder is there, air is going out, blade rotated one direction. Now, when it will be inhaling, when air will be sucked because of wave action, again air will be coming from top. When coming from top, you see this blade design in slides, air is coming from top, again same guide vane is giving direction, it is going through crescent shape blade and exit, right. So, same thing happening. So, blade is getting same direction force, my blade is like this, air is going hitting this one, this direction moving, from here also same direction force, it is moving in same direction. So, blade will be rotating in continuously one direction, air direction changing, but blade is rotating in same direction. Okay. So, this term we use unidirectional turbine, sorry, bidirectional turbine people use, but actually bidirectional airflow turbine. So, airflow is bidirectional, turbine rotation is unique. Okay. So, this is specially designed turbine for wave energy converter oscillating water column. Okay. This is called impulse turbine. Another turbine is that is called Wells turbine. Wells turbine blades are, you can see right side, this one topmost right side, that airfoils of blades are symmetric airfoils. Okay. So, if symmetric airfoil is there, okay. So, here all the pictures are there. Symmetric airfoil like this means this curve, upper curve and lower curve symmetric, same, just mirror image about this axis. Okay. When air is going above this surface, rotation, your force direction will be like this. When air is going from this direction also, force direction will be same. So, blade will get same directional force. Okay. Although air flow changing, this is symmetric blade. Even crescent also, you see this is symmetric crescent, both side, upper side, lower side same actually. If you see this one, this is my actual turbine blade we tested in our laboratory. I think we can show also in laboratory, I think if you go you can see my laboratory. This is also symmetric blade. This is actual turbine we designed, we tested and we handed over to NIOT, National Institute of Ocean Technology, they tested in the ocean. This is the actual turbine. Okay. You can see this crescent shaped blade, symmetric, purely curved, right. So, fluid will be going like this and it will be exiting like this, and my guide vane will be like this, here guide vane, and here exit guide vane, and my fluid going through this, hitting this blade, again moving down, moving out. Okay. And all the 36 blades is there. So, 36 blade will get some energy, all energy if you collect. So, sufficient amount of energy, so that it will be rotating continuously. And Wells turbine also 5-6 blades will be there. So, using 5-6 blade you get some energy, it will be rotating. Okay. And this is actual guide vane actually, right side top left corner. This is actual guide vane, metallic made. This blade we made using 3D printing machine. So, that is why this white color blade is there. But my guide vane blades, guide vane means I told it is not taking energy, it is just guiding fluid. Okay. Only my blade is taking energy. Okay. Guide vane is guiding. So, if you read any steam turbine, other turbine system also, guide vane meaning is that it is just directing. Okay. So, guide vane specially designed like this bend is there, then there will be my turbine blade here. Okay. This is actual turbine and guide vane. This was tested in my laboratory and NIOT tested in the ocean for oscillating water column system. Okay. And this is air flow, I think this is not working. Okay. And another turbine you see bottom portion. So, many people were trying to invent new type of Wells turbine, other turbine. So, one of my students Tapas Das, he is in Newcastle postdoc, he designed this one to biplane Wells turbine. So, you can see this one single plane, one hub is there and blade 4-5 blades will be there, but he created 2 planes and he added 4 more blades in one plane, another plane. So, that he tried to increase efficiency and total operating range. Wells turbine main problem or this OWC main problem is that operating range is very small. So, air is going up, air is going down. So, sometime air, when air is moving up, very high velocity, low velocity, low velocity, high velocity, low velocity, it is happening like this. So, air is not like same velocity, V equals 5 meter per second till here, again 5 meter per second, it will not happen like this. So, 0, 1, 2, 3, 4, 5, again 0, again increasing high velocity, again 0. So, air will be changing velocity continuously, right. So, when low velocity is there, you are not getting power, because turbine needs certain amount of velocities, then you will get enough energy to rotate. But your air velocity very low, it will not be able to rotating, right. So, if so you need certain amount of velocity. So, that means when air is moving up and down in OWC, so when wave is starting moving up, so that time you are not getting energy because air velocity will be low. Again when moved up, again it is trying to going down, again velocity low. If you see sinusoidal profile, sinusoidal means lower peak and upper peak, you cannot harness energy because velocity will be almost 0. So, middle portion only you are getting energy. So, sinusoidal profile, energy, 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 energy. So, you are getting cut energy. Okay. So, we try to design such a turbine so that our energy, can we get continuously energy. Okay. What will be the turbine's shape and size so that we can get energy from all velocities of air. Okay. Another thing was happening in Wells turbine, you may have listened this term flow separation. Flow separation means if velocity very high, flow will be separated from turbine blade surface. When turbine blade flow separation is there, flow is not attached, again your energy production will be very low. When energy production is very low, then there is no use, right. That means you are not getting energy when velocity low, velocity high, velocity low here also, right. Wave is moving up, so here no energy, at the top also no energy, again you are getting energy, no energy, right. Here you are getting energy, here, break energy you are getting. Now, I am saying like if very high velocity there, flow separation will be there. If flow separation is there, again you are not getting energy. That means you are getting energy, no energy, energy, no energy. So, no energy part is more than energy. I think I will explain how things work like this. Okay, let us say I have one blade. Okay, this is called airfoil. If you are a mechanical engineer, you may not be knowing, but this term is called airfoil. So, airfoil means low velocity. When fluid velocity low, fluid will be touching the blade surface. When fluid is touching blade surface, life is good, you are getting more energy. Okay. And so, low velocity it will be touching and you can get energy. So, the two term we use, lift and drag. So, we are getting good lift. Okay. Drag means is negative, you assume it is negative, lift means good. So, fluid is touching means good, but low velocity means it will not have too much energy to give good lift. Okay. Now, you increase flow velocity, what will happen? So, fluid will try to move at straight line, it will not try to follow the curvature of the blade. When it is not following curvature of the blade, there will be flow separation, flow will be separated and it will be creating like you see this circle I am making. So, this is called flow separated area. If fluid is not touching the surface, fluid is separated, that means fluid will not give energy to the turbine blade. Fluid is having energy, but he is not giving. He said, hey, my velocity more, I am not touching you. Okay. So, in that case you are not getting energy. That means when wave at lower position is here, then wave moving up like this, alright. So, here air velocity low, wave velocity low, here wave velocity or air velocity low, here low, you are not getting energy because low energy, right. Here you have this area, higher air velocity is there because higher wave will be moving at faster rate, energy good, but problem is that flow separation. If you have too much velocity, your flow will be separated. Then what will happen? This portion you are getting energy, this portion you get energy, this portion, center portion, flow separation. That means your energy will be like this. Right? Your bottom curve, this portion, this portion, this portion, this portion. So, cut energy you are getting actually, Wells turbine. Now, if you can join these lines more better, right. So, that was our target. So, we designed different types of turbines, we designed design optimization using machine learning, all this algorithm, and we try to increase the operating range. We say operating range. For wider flow range, it should give good power. Okay. So, if you are not considering Wells turbine average efficiency and all these things, many people will be saying, but if you see minutely, actually you are getting small power, small power, small power, small power, small power. You have to add all this. Then whatever power you are getting, that is actually your power. Okay, theoretically continuously curve you are drawing and you are giving maybe integration of x, y, z. So that is not your power. Okay, so your target should be how to connect this instead of small dot, right, discrete lines. So that was a target to connect or to reduce the gap. Okay, so that's why we designed many types of turbines, and we handed over some turbine to NIOT, and remaining we publish in papers. You can see our papers in Google Scholar and Scopus also. OTEC I already explained that OTEC will have low temperature 4 degree, right, surface temperature 30 degree maybe. So normally it may not be like 27, 20 degree, NIOT run their system about 20 degree. Okay, so low temperature water you take, piping system you make, steam you create, then you pass through turbine, then again put in water. So this cycle will continue in OTEC system. This is closed cycle system. But if you are using open cycle system, then the whole cycle will not be there. They will be using water certain way and they will be running the system. Okay, so it will have one heat exchanger. If you have closed system, heat exchanger means heat, like say your ammonia is having higher temperature, the temperature must be reduced and it should not be mixed with water, sea water. So it will be passing through pipe or some exchanger system, and outside cold water will be releasing heat. Okay, so there will be heat exchanger. So if you are from mechanical, so you know the heat exchanger, right. So in surface also there will be one heat exchanger. So two heat exchanger will be required to change your temperature, and one turbine system will be there. One pump also will be there, otherwise because from 4 degree to 30 degree you have to pump water. Okay, and efficiency normally 2-3%, and is very low efficiency system actually. 1 or 2% efficiency if you get, very good, your life is very good. Why? In offshore area you are working and very much expensive, and many people saying so much investment, where are you working? So some other argument is there, energy free, you install, forget, you get continuous energy. Okay, that is why still people are working, and some people, for example Lakshadweep, they are our citizen, so they also have right to get electricity and same living standard as people in Chennai they are getting, right. So how can you give energy power to them, water, energy, power, whatever you say. Okay, so any question? Yeah, so Indian tidal power, there are two locations government selected. One is Durga Dwani, West Bengal, Sundarban area, another is Gujarat Kambe area. So in West Bengal, government Durga Dwani, the government investment, everything they tried, but expenses was very high. You have to construct dam and low lying area, they will flood and all those things. Finally they abandoned the project. In Gujarat area also expenses was very high, surveying and so many things were taking time. So they abandoned, but again I heard that government is has given some detailed project report they are planning to install some dam and tidal turbine system. So that will be used for dam and connecting two cities. So that sort of thing they are planning. Okay, other small turbine system NIOT trying, like IIT Madras we are doing some academic research, NIOT has tried something, small work going on here and there. Okay, but major two areas, two locations are there. So yeah, so government is trying for Gujarat area and West Bengal area, I don't know, maybe in future government will be taking. Okay, Andaman area also some water flow area is there, so NIOT tested their system actually there. Okay, yeah, you have any comment, any suggestion, any question?
Telling about that old technology.
Ah.
That has to be done only that vertically for higher temperature and
Surface?
front distance, and for the colder region.
It's long pipe will go.
So that will be vertically.
Vertical pipe, I think NIOT not putting vertically, because your machine should be on land. Okay, so they are putting machine on land, machine and everything. So pipe is going longer distance to colder area. Okay.
So but why it is not possible? So like summer time it is not high temperature only. Is that possible to generate use that OTEC during summer season?
But you are giving so much investment and you are using for only few months, so that may not be economical, because your investment, manpower, security, safety, I mean, continuous expenditure will be there, and you are using for only few months, so that may not be logical. Okay. So, that is why they are trying to capture from wide range of temperatures. Surface temperature may be wide range, maybe 4-5 degree or 10 degree temperature difference, still things should run. So, that winter season also people should get some power.
So comparatively, OTEC will give less power only.
Right. Yeah, so technology is still not mature, so people are trying to get more power. I said like lots of energy there. I mean, OTEC also can give all the energy of the world, but you need technology. Okay. Or you have to close all the well bores for oil and gas, then people will be focusing on renewable. So, that is also not feasible. Okay. Okay, please.
We install so many turbines of this thing. What is the life of the turbines?
Turbine life, that I do not know. Professor, any idea for turbine life?
No, I think this certainly they operate very long time. The only thing in the salty environment, they need a spray fresh water to remove the salt.
Salt and biogrowth, biological growth, algae and other thing will be growing, so that also cleaning will be required, otherwise dynamics will change because of extra mass. Okay, thank you very much.